Alright, my name is Derek Wynn. I'm going to be doing part C of the Fluent Flannel project, which is a flat plate in a wind tunnel. I'll go ahead and start making this. Open up the geometry, new design modeler. Okay. Go to sketching. Just draw three horizontal lines here. Okay, and then we're going to go to dimensions. Get the length for each of these. And this is going to be for the contraction cone, the test section, and the diffuser. Alright, length for contraction cone is 1.176. We can keep it in meters. That works out just fine. 1.2192. Test section, and then 1.5748. The diffuser. Then we'll draw a line for all this, line to end here, and then we'll have, go into constraints, midpoint. Okay, and then just make the midpoint. Make the midpoint of this line here. Perfect. Okay, and then from there, I'm going to draw 4 vertical lines that roughly resemble verticals, diffuser, the contraction cone, and the test section. Go back to constraints, midpoint, we'll just attach it to each of these points here. Last one. Okay, now dimensions. We get the vertical heights for all these. Alright, and then go into document. Diffuser inlet's going to be 1.6256 meters. 1.6256. And test section is going to be 0.6096. 5v6 is the same, 0.6096. And then diffuser outlet is going to be 0.889 meters tall. Okay, and then I'm just going to draw some lines here and connect everything. Perfect. Okay, and then I'm going to go into select and just delete the stuff I don't need anymore. Select all these height values and length and stuff like that. These center lines I don't need. Okay, that's all good. And then because I'm doing the flat plate, I'm going to go ahead and draw that. It's a rectangle. has to be 0.5 meters according to the document. Make this 0.5. Also, oops, zoomed too far. Okay, also gonna constrain this, make it centered in the wind tunnel, and just so it's more into the test section. Yep, that's 0.5. I'm gonna go ahead and then draw. There we go. Okay, cool. And then before I shrink everything down, let's constrain this so it's in the center. Oops. Okay, so I'm just going to move this whole thing here. Hit the move section and modify. And doesn't have to be perfect, but definitely want to be more centered in here. Alright, that's good. Nice. Okay, that's done. Length still 0.5. And then for the heights, I'm going to change it to 0.5 divided by 1,000. But I'm trying to just get it to the center of the wind tunnel. Here looks like it works. Actually, oops. Do that. I got one edge. concept. Surfaces from sketches. Select this sketch here. Apply. There we go. Very nice. Generate. There should be a small little hole there. Yep. Okay. All good. I can close this out. And then start the mesh. Double click this for the mesh. Wait for it to load. Awesome. Let's go ahead and name all the edges first. Go to edge select. Okay, nice, all named. And then from there, start the meshing. Just do a basic method. Select this. We're gonna turn this just triangles, and then go ahead, generate that. Then I'll have a super basic triangle mesh. Very nice. Alright, then we'll do sizing. For this one, I'm not going to do inflation because it's really not needed for a super duper small flat plate. So we'll do mesh, insert, sizing, hit that, apply, do element size, do 0.01. Otherwise it's going to take forever to render. Go ahead and hit generate on this. We all good. And then we'll do some edge sizing as well, just to cover my bases here. Okay. Mesh. Do insert. Sizing. Take the edge. And just select all these. There we go. that it's going to take forever. It should be 5. After curvature, no. I'm going to set it and make this hard. Okay. And then we'll generate the mesh. And I'm just going to pause this. You don't have to. Okay, all done. Look at the mesh now. Alright, that's good. And now there's like a definitive thick couple lines around the plates and whatnot. Actually, I think I can go a little bit finer on this. Okay, I think not. I think this mesh is good. We're gonna go back. Gonna hit this, update, get the green check mark. Go into setup now, load this up, and then we're gonna do what pops up here. Here we go. Double precision, and we're going to do 4 solver processes because my computer can handle it. Start this. I'll come back when it's done loading because it usually takes a little bit. Okay, load it up. I'm going to head into models here. I'm going to change this to edit. It's at K omega right now. I'm just going to change it to K epsilon. Do standard, enhanced wall treatment. Here we go. Do pressure gradient effects. Press OK on that. OK. You know, I'll turn the energy on as well. Let's put that to on. Edit this. Thermal effects too. Okay, I want to see that. Not really necessary for this lab, but might as well have it. Okay, all good for there. Materials, fluid, air. Don't really have to change anything here. Just keep it as is. Didn't really specify anything else. Yeah, use air as an ideal gas. Okay. Density's good for that. Yeah, that's fine. I can close that out. All good. Good. Cell zone conditions fluid. Just make sure it's using air, not something else. Yeah. Okay. Okay. Take a look at the boundary conditions. Inlet. For the velocity inlet, that's going to be coming through the contraction cone. And we want the test section velocity to be 15 meters per second. So using the height ratio, you end up with 15 times the height of the test section, which is 0.6096 divided by the height of the inlet. And so for the inlet, you want the velocity to be 5.625. Okay. Close that. Everything else should be good. I'm just going to check the lines. reference values, computing from the inlet. This is going to be velocity inlet. Yep. Okay, good. Velocity is going to be 5.625. Yep. This is good. This is good. Everything's all set there. Reference zone is going to be for the surface body. Oof. Change it to this like an arbitrary value, I guess. Go to solution, methods, make sure this is coupled. Second order upwind. Before I initialize, I want to change my residuals to make it a bit more accurate. Okay. And then we'll go ahead and initialize. And then we'll run the calculations. Number like 1,000, just so it's going to converge, and then I'll calculate. I'll be back when it's done. Okay, so calculations are done. What we want to do now, I gotta get drag coefficient, and using the formula for drag coefficient or a derivation of it, because Fluent takes the drag force at the velocity inlet, I want to find it in the test section. So what I'll do is I'm gonna take reports right here, yeah, so I'll do report definitions here. I'm going to do force report drag, get the drag force at the plate top and bottom here. I'm going to print it to console, which gives me 1.06865, and I'm going to put that to get my drag coefficient. I'm going to divide that by 1/2 rho velocity of test section squared times the length of my flat plate, which gets me 0.0155 as my drag coefficient. From there on, I also need the wall shear. So I'm going to go ahead, get wall fluxes, get the wall shear stress at the plate top and bottom, and I'm going to write it to file, and then I have to plot this along with the skin friction coefficient, so I export it to Excel. So I'm going to write this to a file. Let's do computer. I think I'll just save it to my downloads for now. I'm just going to save it as Fluent final wall shear. Okay, that's it right there. And then along with that, I'm going to do the skin friction coefficient. It's not the worst. Could improve somewhat, but it's not terrible. I think it's just the meshing. That's why it's not as flat. It should be okay. Okay, so you got skin friction coefficient. I'll write this to file and save it into our downloads. Call it skin friction final fluent. Okay, and that's that's all done. I'm just going to check on the side here to make sure it's saved to my file. Alright, so both of them saved, and we're pretty much done here. I can head back to the workbench. I'm going to go ahead into the results now. I don't know why this is here. I'm going to go ahead and click on results now so I can get the velocity and pressure contours. Let's wait for this to load. Okay, there's the flat plate there. I want me to zoom in. So first I'm going to make the velocity contour. Okay. Means location. It's going to be velocity inlet. Do 110. Okay. This one's going to be velocity. Apply. Oops, wrong place. Try here. There we go. Okay. Cool. So did with the symmetry. There's going to be my velocity contour, and I will zoom in on the flat plate for this and take a screenshot of it when I'm done. But that's the velocity contour. Just double check something here. Yeah, zoom in on the flat plate. Okay, so that's velocity contour. Good. I'm gonna turn this off for now, so then the pressure contour will show. So do my pressure contour. Okay. Do symmetry 1, pressure 110. Apply this. Alright, and here's what we got. It's because the plate's so thin, really, but you can see here that pressure is decreasing and then increasing again. Alright, but that's all for the project. Thank you.